Cool. So I've known two of these people for many years, but Toghurl, it's really nice to meet you.
Nice to meet you too.
Yeah. Welcome to the back to the conference circuit. You know, how's it going? All right. Why don't we start out with like introductions? Who are you, and a little bit about ZK Sync and Scroll, and I think Uri gave a good introduction to start that. So.
Sure, happy to start. My name is Alex Gluchowski. I'm CEO and co-founder of Matter Labs, which is the company behind Zaki Sync. We have a specialized Zaki rollup on mainnet now for payments and swaps. But now we're working on the EVM-compatible Zaki rollup for which is the version 2 of Zaki Sync, which we have now live on testnet. So it's the first Zaki EVM live on testnet.
I'm Toghurl Maharramov. I work for Scroll. I'm a senior researcher there. So what we do is we're building an EVM equivalent rollup, a ZK rollup, which uses ZK EVM, which is implemented by us and Ethereum Foundation as a collaborative effort. And we're planning to launch the testnet somewhere around the end of the year, and hopefully the mainnet by next year.
So I'm Louis. I'm the ecosystem lead at Starkware. I'm going to repeat still what my overlord Uri said before. So Starkware is a zero-knowledge company. We do scaling through the usage of proof systems, specifically Starks. And we have been, settling over $1.5 billion. Wait, what's more? $350 billion sorry, was it like, 1 or 2 order of magnitude through our customers, DYDX, Immutable, Sorare, and Diversify, and we have been launching the first production-ready ZK rollup in production on Ethereum today. So if you want to try it out, have fun.
Awesome. Yeah. Okay. So let's like kind of get into it. One of the questions that we were discussing in our chat is this question of decentralization, and I think Uri like sort of started this question with this. Starknet has a single sequencer. How do each of you think about the sort of trajectory towards not just having scale but decentralization in sort of general purpose zero knowledge execution?
So maybe we can begin with the question: what is decentralization? Why it's important? So
sure, absolutely.
For us, at Zaki Sync, we are following the philosophy of Bitcoin, Ethereum, the decentralized public blockchains, where decentralization is important to ensure that no one has complete control over the network. There is no single point of failure. There is no single point of leverage. So we don't want the blockchain world to devolve into something that happened to internet, which began as a decentralized network of networks, but now it's essentially controlled to a very high degree by like 5 corporations. Because of like natural process of centralization of power, of amassing of resources. So we need to prevent that. And the way to prevent that is to put the control of the system in the hands of the users and making sure that the community always have the leverage over the developers of the protocol, over the operators of the protocol. So like if something happens to Ethereum, and it's like, let's say, miners or like validators in proof of stake after the merge become malicious and like have a malicious intention to control the network, extract value from the users, the community can always coordinate and fork away. And this, for me, this is the very fundamental thing which we want to preserve in Zaki Sync by having permissionless software license, by having the network governed by the community, but also supporting, even though we hope it will never happen, ability for mass exits, mass transfers to a fork of Zaki Sync or to any other rollup which will preserve, which will keep this philosophy. But it's also important to keep decentralization in layer 2 itself, which is why we're working on a decentralized consensus for inside layer 2 to make sure that the transactions also remain centralized.
I guess maybe it would be a bit better to start this question. Why is it particularly hard to decentralize sort of execution with the zero knowledge technology? Why, like we've had decentralized blockchains now for 10 years. What is the unique challenge that comes out of zero knowledge that like makes decentralization question more of a challenge. Do you want to?
Yeah, I guess I can take it. It's more that I mean, there is no real challenge. It's an engineering challenge, you know. It's only engineering, as people say, except that it takes time. So we're going to make it, right? We're all going to make it. We're going to make it decentralized, make it open source. Everyone will be able to run it. What's complicated though is that you have less flexibility when you build an L2 than when you build an L1, because as opposed to an L1, at the end of the day, L1 is relay on an L0, and you can always roll back. There is you can do things. On an L2, the problem that you have is that you have this bridge, and when something is a bridge, valid the proof, and the money is out, the money is out. You don't control anything anymore. And so the bridge is the most scary piece of software when it comes to L2s. And for the funny story, the reference paper, and that no one think about it, but the reference paper on L2s, it was written by Patrick McCauley, and it's the name of it, and I would think about it, scaling blockchain through, validating bridges as a scaling solution. Because at the end of the day, everything is about the bridge. And so now there is a bunch of challenges also with the proof system, which is, you need to have, all of a sudden you don't have only executors and your sequencers, you have this proving, and this proving has this latency, and you want to make the sequencing as distributed as possible, and the proving also, and you have a bunch of challenges that exist elsewhere. And so there is a bunch of engineering challenges that still need to be solved, and we just want to get it right, so it takes time.
Can I add? I think the problem with L2 specifically is that because we're already outsourcing the consensus to an L1, the goal of an L2 is to minimize the overhead, which is consumed by the consensus. So adding a consensus on an L2 doesn't really make a lot of sense because it just will add the same overhead that you already are trying to outsource to an L1. So the point is, how do you decentralize in a way which also minimizes the overhead? And it's quite difficult to achieve, especially with ZK rollups, because the prover efficiency is not great, so it consumes quite a bit of computational energy to compute the validity proofs, and we need a way to make sure that the system remains efficient, but at the same time, people can just join in and participate without an issue.
So, yeah.
I just want to add, we're here at the Modular Summit, so we should think about the decentralization also in a modular way. There are multiple layers that can be decentralized with regard to layer 2. The first is obviously the bridge itself and the general ability to control it, to upgrade, to exit, and so on. Then there comes execution, which is actually easier to decentralize than layer 1s. We have less challenges because we can always tap into Ethereum as a court of a final appeal to resolve disputes. So our consensus mechanism is actually simpler than the one required for layer 1. And we can also have some significant advantages. We can reduce the number of validators because we don't depend with zero-knowledge proofs on them for security. So we don't need, we don't need such a large number. We can have delegated proof of stake, so we can reduce latency a lot. And we can have very fast confirmations for transactions in layer 2. But then there comes also zero-knowledge proofs generation, which is a layer on top of that, which can be decoupled from the execution layer, which can happen asynchronously in some time, which is probably going to be much lower than what we currently have. It's going down under a minute, some seconds, but it still needs to happen, and it needs to happen in a decentralized way. We don't want to depend on a single provider, on a single cloud, or on a single powerful player for generating the proofs, not to have it in the supply chain as a point of failure.
Well, so do you imagine that there's going to be economic incentives eventually in these systems for generating proofs? How are we going to convince somebody to spend, a huge amount of money at AWS?
I'm going to troll my colleagues here. So we have a Starknet research group internally where we discuss those things, and this question about how you decentralize this has been an open, making joke, we have ideas and direction, but an open question for 9 months. To a point, I dropped the meetings. Just for a joke, but no. There will be obviously incentive. There would be today we only pay the sequencer, either through leader election, through proof of work or proof of stake. But there will be the same kind of mechanism. Now, you're perfectly right. The challenge there is, for instance, if let's give you a random idea, which is, oh, let's make a competition. And then if you make a competition, that's great. It's like, just the fastest gets to the network, we're all happy, whatever. So the main issue you get with that is that it basically brings down to centralization, because the fastest guy, the most efficient guy would always win, and there is no incentive for the others to make it. And so all of a sudden now you're relying on one or two single point of failure, and your system is not redundant. And while he cannot, of course, steal money because it's a zero-knowledge proof system, whatever, because of the bridge, it still can store the system, and you don't want that property. And so you need to come up with new design and find the right trade-off on this latency decentralization, which still is an open question to some extent. Cool.
But to come back to the original question, if there is a work that needs to be done, if there's something people need and they were willing to pay for, there will always be found some market mechanism to provide this value and to get compensated for this.
Absolutely. I think, I think the progress in the fact that we even have test nets and main nets of general purpose zero knowledge computations is just insane. From the first time I saw the zero cache paper in 2014, it's just been I can't believe that we've made so much progress in 8 years. But what do you think? What have been the challenges in building execution environments? You each have sort of very different models of sort of how the zero knowledge is actually executed. How do you differentiate them or think about them as being different?
So for us, our main goal is to be EVM equivalent, which means that you can copy the bytecode, a smart bytecode from Ethereum, and just plop it on Scroll, and it'll just work without any need for transpilation or any other fancy trickery to make it work. And the challenge with that is that EVM is not really circuit friendly and zero knowledge proof friendly. So a lot of the opcodes and a lot of the functionality inside EVM needs to be made in a way which minimizes the overhead inside the circuit. And that's quite challenging to do while also remaining efficient. So that's one of the main challenges for us that we're tackling right now. And the way we're trying to solve it is by using hardware acceleration. So we already have a GPU acceleration accelerated implementation, and we're working on FPGAs as well. And we're just going to see whichever.
But doesn't that make decentralization more challenging?
To some degree, it does, but it depends on the incentives. If you provide enough incentives, there are going to be always enough people who are going to participate in it.
About the decentralization challenge, I just want to bounce into things here. The first one is we all have the same challenges. We basically have the same problem. We want to separate the sequencer, we want to separate the prover ideally. If we don't, we're just going to merge if there is no other way, but basically we have the same technical challenge. But the trade-off that we all have is different, targets. The Starkware just took a different bet to say, you know what, EVM is great, we all love it, but seriously, it's a piece of crap. And let's do something that is optimizing for proof, right? I'm going to rephrase that. It's a great software, and it could be improved. And making jokes, but it's Starkware just decided to say, you know what? ZKPs have a different computing paradigm. Just deal with it. Just accept it and embrace it and be as fast as you can using that paradigm. And then you can retrofit stuff if you want afterwards, but optimize for the performance. And Scroll obviously is going for pure EVM, EVM compatibility or the ability to actually prove blocks on Ethereum. And DK-Sync is optimizing for simplicity of developer experience based on previous experience. If I summarize it perfectly, I would let you bounce on that. But the question now about decentralization is, the decentralization, as we say also, is less important for a ZK rollup than it is for Ethereum or for an L1. And because decentralization matters on ZK on the L1 because you need it for consensus. You need to know that the state you're holding is a true one. You need that. Otherwise, everyone could lie to you. When in a ZK rollup, you're like, I just need for censorship resistance. I'm not going to be lied to, because they cannot lie to me because of the proof. So I just need like a bunch of incentivized people. Probably I don't even give numbers because we want as many as possible, but it could be smaller, and it's not necessarily a big deal.
So I think the ZK Sync CPU target is kind of very unique. You want to sort of explain?
Sure. So as Louis correctly said, we've chosen the middle ground between the two extremes of having EVM equivalence and having a completely separate, like from scratch execution environment. What we're trying to maintain is a balance between the, not a balance. We're not making compromises. We're like, we want to get the best of both worlds of the super efficiency which zero-knowledge proofs can provide if you make them, if you optimize for them specifically, and having a fully EVM-compatible chain where you can take essentially any application written for EVM chains in Solidity, in Viper, and other languages. Just port it on ZK Sync, and it will work out of box. With full Web3 API access, with your deployment scripts, with all the tooling that you depend on, it must just work. But we're not willing to take the compromises, in the penalty in security, orders of magnitude more, sorry, not security, performance that you would do if you went for full EVM efficiency. So the challenge for us was, there were a lot of challenges, like you just go them one by one and you tackle them once you set your priorities. But like one specific example would be, we need to follow and fully preserve EVM security model. And what we're building is a hybrid solution. It's evolution between ZK Rollup and ZK Porter, which is a data availability off-chain solution, which is connected to ZK Rollup. So users can choose whether their account is fully secured by Ethereum or has this external data availability layer, which makes some assumptions about security. But the challenge was like, how do you maintain the security model of Ethereum? Because the rollup contracts cannot depend on the Porter contracts. Like if their data becomes unavailable there, how do you make sure that the users can still always withdraw their funds from the rollup, and this can be enforced by Ethereum? So there were multiple layers of thinking there. One is that we need to ensure that every transaction is executable in zero-knowledge proofs, even if it fails. So we don't only accept transactions that are valid. We can accept invalid transactions as well, without coming through priority queue on Ethereum, and we will always execute them no matter what, and just if they fail, we will prove that they fail. But there was also a challenge of like, how do you design this interaction between rollup and Porter in such a way that to protect to like 100% secure rollup users no matter what happens on the Porter. We found a solution, and we're going to be happy to present it once Porter is out.
So, Louis, the challenge with having your own sort of CPU target is you've had to build a developer community around zero knowledge, right? So how is that?
So, to be honest, so like let's say that 9 months ago, or before, since I've joined Starkware and we've been talking about Cairo, everyone say EVM compatibility, like it's like the fucking gold. And the truth is, like, it was at first we were very worried. Like, of course, we have to start a community from scratch. And the counterintuitive thing is that it actually helped. The counterintuitive thing is that, we are not gathering. I mean, the whole thing we're going after today is not to cater to the let's say 20,000 Solidity developers worldwide, 30,000 different Solidity developers. We are all the new guys. They are, willing to accept something new. They are trying something new. And even worse, they feel that they're bounded by fire because Cairo is hell. And so Cairo is our CPU and a language. So the truth is, we have seen a surprisingly interest from the dev community, from people who came from existing Solidity dev, from other places in the world, just popping up and learning it and improving the tooling and having extremely dedicated community. And without sort of buying their way, we just explain them, talk to them, give them ideas. Fostering the community basically helped and worked. And as of today, I would say that worldwide right now, on a daily basis, there is around 300 to 500 dev 9 months after inception. So that's pretty successful, and the growth is not stopping at all. So for now, we are consider pretty safe with our bets. So you say people are willing to learn new things.
I certainly see you tweeting some new exciting thing like every single time I wake up in the morning.
Yeah,
It's like,
I know. I mean, at this point, I'm like a cheerleader, like a echo chamber. Like, I have to say, if you're a dev and you want to, I always tell to the dev who wants to actually break into the space that the most important thing they need to do is, I have two things that I tell them. The first one is, it's better to be early than to be great, which means the following thing. You're better off being early in ecosystem than coming from fucking, DeepMind and going to make Solidity dev right now. Why? Because you are all of a sudden facing people who have been doing that stuff for 5 years. And you're like, you don't know the foot guns, you don't know all that stuff, and you're going to be like competing with people that are just, better than you because they've been around. On the other hand, if you come early in an environment that is a bit hellish, but at least the fundamental is very interesting, then the competition is a lot easier. Everyone is new. No, there is no great dev. There is no sort of magic trick that you know. And so that's what I'm saying. I'm saying people, realizing, oh, the tech is super cool. And Web3 looks amazing. But Solidity is already kind of a crowded place. It's not fully, but it's a kind of crowded place. Here I am. There is 500 people worldwide. If I'm bad, I'm better than anyone else. And so that's the second one. And the second one is, I always tell them, whenever you do something in this space, you're going to break in by being visible. And the only way you do that, and that's magic of crypto, is that everyone is on Twitter, and Twitter is a very easy marketing tool. So every time I'm telling them, oh, you do this paper from Paradigm, just tweet it, I'll retweet it, and the community is being what it is. It's basically retweeting and a lot of excitement. And, I got like at least 5 or 6 people getting hired just because they posted 3 tweets. Hired OpenSea, hired various places because they just become visible. So yes, I've become an echo chamber, and I don't do much in my life except tweeting.
So people should just follow you.
Actually, don't.
I think you should follow all 3 of them.
Yeah, you should, but it's really boring.
Not him though.
No, not me. It's very boring. It's like it's advertisement. Just don't do that. But if you want, if you go bored in your life, feel free.
Okay. I think we're supposed to get off the stage around now, right? You have time? Okay.
Yeah.
What? I thought we were going to transition, so now I have to come up with
We can take questions.
Let's do questions. Cool.
Yeah, any questions?
I have one question for Louis.
Oh God.
There's
token.
time. I saw you first. I'll give it to you.
Wait.
Sorry, guys.
Hey, so we discussed at some point ZK over consensus, right? So one of the properties that we have for off-chain computing is that we're not time constrained. So we can perform any proof there and just use this in the chain. So for the consensus, this is more complicated since we're time constrained. And maybe we cannot even benefit from some state-of-the-art techniques such as recursions. So how do you guys see that? Should we expect some improvement on the current state of the research or the implementation to make this feasible?
So to summarize the question, if I may, you're asking about ZKL1s and recursion as a tool for improving what? I'm saying
Consensus.
Consensus, okay. Anyone want to take it, or do you want me to take it?
I think those are actually orthogonal problems. Like you don't improve consensus, you improve other things. You can significantly improve decentralization if you implement L1 fully, let's call them fully succinct L1. What Mina protocol is doing, for example, right? So it's a lot easier for everyone to verify for full nodes. You don't have to re-execute all the transactions. You just verify 1-0 knowledge proof, which will take you 30 milliseconds or something. And the rest is just data availability, right? So it's a great approach if you can. The challenge would be to compete with big established ones, but at least that's something where you can differentiate from them. But I don't see it affecting the consensus mechanism as such in any way.
Also, bear in mind that a lot of consensus mechanisms are synchronous or partially synchronous. And when you use validity proofs don't have a sense of time. So there's no way you can use validity proofs to optimize consensus in most cases.
Yeah, but the added time to prove statements for the consensus. So the proof is far more expensive than the verification. So to verify it's trivial, to prove it's not. So that's the main problem.
Alex said, the proof generation can improve some bits in some proof of work stake, like weeks. There might be something about the weak subjective weak checkpoint or weak subjectivity checkpoint or something like this.
Weak
Maybe
subjectivity.
yeah, thank you. Like there can maybe some improvement there, but the main thing that you break when you have a ZK at the L1 level is that you are improving the topology of the network, meaning all of a sudden you have validators that can, node, non-mining node, non-sequencing node that can be on your phone, and the miners or sequencer can be on a fucking data center for they care. And so all of a sudden you can be increasing your throughput dramatically Solana style, but you still have the decentralization that you're hoping for in L1. So that is not the consensus level though. It's at the topology of network topology. Cool.
Okay, perfect. Thank you.
There
think
was one more
another
question, right?
question
Yeah.
in there.
Oh, perfect.
All right, thank you very much, guys. This question is for Louis, because you were dunking on EVM. What would you change about EVM?
You want all the
We're going to be here for a long
Let's
time.
let's give it a top 3.
top 3. You win 256 as default. Kitschak as default hash function, which is like why from the get-go. This is not technically EVM, I guess, but hexadecimal tree for storing state. Top 3.
Those are all on Vitalik's list too. So
What?
those are also on Vitalik's list. Of
Right. I mean, that's.
what he regrets.
I can rest. I can rest in peace. Yes.
Just copy paste.
Exactly. No, they're the top 3, right? What else? The choice of 80 bytes addresses is a mistake.
RLP.
Huh?
RLP.
That's something I don't even know, right? Like there is a bunch. You can continue there, but
Okay.
I'm not even the expert in VVM. Just the top 3 that come because when you work on ZK, you're like, why did they use Kitschak? Why did they do that? Like, could they use like SHA or oblique 2S or something simpler, like or standard?
Preferably Poseidon.
Yeah, but whatever. Like, actually, we don't use Poseidon for the story.
We
don't
do.
use. Huh?
We would have.
Yeah, no, we don't. because
Otherwise.
Start for the story by that actually the hash function. So Starkware is very conservative in its primitive function choices, and so you have to understand that the biggest thing the hardest thing to prove, or the most consuming in the proof, is usually the hash function. And so most of the industry have been using Poseidon, and we are using Peterson hash, which is provably secure, but 10 times worse to prove. And so we kind of like to shoot ourselves in the foot with being conservative sometimes. So here's one example. Conservative doesn't mean better or different. It's just like it's different. It's just such a choice. And I kind of hope one day that I will convince my engineer that Poseidon is fair, is good enough. We can adopt it. But for now, we're still struggling with that. So
we gotta wait for someone else to settle like $1 trillion on Poseidon hashes, and then
right, exactly. That's kind of the story here. Yeah. Exactly. So just the answer.
All right, thank you very much.
My pleasure.
Any other questions?
Toghurl, you had a question.
Yeah. Okay.
Yeah, right there.
Okay.
I see
you
Alex
guys-
interesting Toghurl's
You guys
question.
have more time.
This is a question for all 3 of you, or 4, if Zaki you want to throw in. What proof systems are you guys kind of like most, interested by, or kind of like where it could go? Take it Bulletproofs, Marlin, Halo, the list goes on. Like, what of those ZK proof systems are you kind of most stoked about?
Yeah, I saw it. I think we know your answer. It's on your shirt.
Starks.
I saw Ariel yesterday, and I was like, "You won!" Like everyone is using Plonk, like except for the Starks people. And the arithmetization inside of Plonk and Starks is very similar. So it's just like really the last step of the verifier. But yeah, congrats to Ariel for winning Stark Timber.
I just want to react to this. It's a very interesting question. My answer obviously Stark, but obviously that's not the answer for everyone. It's obviously a trade-off. What people don't know though is that every time they talk about Stark versus Snarks, they always care about the theoretical differences, the trusted setup or the non-trusted setup, the quantum resistance or not. The reality of actually why I care more about Starks, to be honest, is because of the proving time. Proving like by default, and which is like why Scroll, I mean, you said they are looking into acceleration is because it's a lot harder to make a Snark proof because it's n log n, but it's n log n elliptic curve operation. When a Snark proof is n log n, but it's a hash function. So the constant here is pretty significant and does have an impact on the proof generation. So it is also why I believe that Polygon basically went only the Stark route because they believe that it's more scalable, at least in the short term.
But you should also bear in mind that long term, we're probably going to be limited by data availability rather by proving times.
Well, I mean, we'll see. I mean, I'd like to say, I like to quote Keynes in these cases. In the long term, we're all dead. So from there, I don't know. I'm just a normal guy. I don't know. Of course, I'm not dunking here at all. I'm just saying that this is why I kind of care more for Starks.
Cool. All right, you guys are done. Thank you.
Thank you.